Now, there are another two statistics we can work out fairly easily that will help with our visualization of the data. These are known as the lower hinge or first quartile, Q1, and the upper hinge or third quartile, Q3. Most of the time I'll just refer to these as Q1 and Q3. The terminology about lower hinge and upper hinge is traditional, but it's not used so much these days. Now, Q1 divides the lower quarter of the data of the marks from the rest, and Q3 divides the upper quarter of the marks from the rest. So if we look at our little visualization up here, what we are going to expect is that Q1 is going to be somewhere in that section and Q3 is going to be somewhere in there. Okay, so the upper quarter will be on that side and the lower quarter will be on the left there. Now, the official definition that we use is that Q1 is the median of the lower half of the data and Q3 is the median of the upper half of the data. In our case, the lower hinge, Q1, is 63, so about a quarter of the students had a mark lower than 63, and the upper hinge, Q3, is 72, so about a quarter of students had a mark higher than 72. Now, when I say about, it turns out that there are about roughly a dozen ways of calculating Q1 and Q3. And it depends on the statistical software that you use. So if you use SPSS, it has one way of doing it. If you use R, which is the thing that I mostly use, it has a different standard way, and it offers about, I think, 9 or 10 different methods. If you use Excel, it has two methods that it uses, one of which is a strange historical thing that people stopped using 100 years ago. So it's going to be a little bit different depending on the software that you use, but in practice it rarely makes much difference, so I wouldn't worry about it too much. So here's our visualization if we add in Q1 and Q3. So I'll just make that a little bigger so that we can see what's going on. So Q1 is marked there with a blue dot and Q3 with a blue dot there. And so what now happens is that Q1 and the median and Q3, they divide the data into quarters. So a quarter of the students are between the minimum and Q1, and a quarter are between Q1 and the median, and another quarter are between Q2, and Q2 is the median, and Q3, and then a quarter are between Q3 and the maximum. So we can see there that the second quarter there is really compressed. It's a very small range to that, which is probably of some interest. So the median is, as I said, is called Q2 also, and the minimum is Q0 and the maximum is Q4. So that's what this Q notation is. These are called quartiles. The 5 of them, Q0 through to Q4, are known as the 5-number summary. And the 5-number summary is pretty much the first thing we want to look at when we get a metric variable. We often also want to look at the mean, the arithmetic mean. But the 5-number summary is pretty much the first thing that we look for. So the quartiles divide the marks into quarters, and that really helps with practice. That really helps with our visualization. Now, I mentioned that the second quarter, the one between Q1 and the median there, that little tiny one there, is very compressed. And the way we would describe that is we would say there is very low variance in that quarter. In other words, there's not very much difference between the marks of the students who are in that quarter. They're all very close together. Now I'm using this word variance there rather informally. There is a, and I will use that a lot. I'll also use some other terms. There is a statistic called variance, and there's a mathematical formula for that, which I'm probably not going to show you at any point during this course, but you probably encountered it at school. The variance is the standard deviation squared, but you don't need to know that for this course. Now, really key thing to note here is that about half of the students' marks are between Q1 and Q3. So just going back up here, half the marks are between Q1 and Q3. And that is called the interquartile range, the distance, if you like. We always talk about it, we think about it as distances. So Q3 minus Q1 is the interquartile range. And that, in this case, is 9 marks. So I've got the calculation there. So this is called the interquartile range, or IQR, and we will make use of that for a calculation we'll learn later on. So we know that half the students receive marks in that 9-mark range, between 63 and 72. So that's a fairly compressed range. The IQR serves as a statistic for the variance, and we also call it the spread or compression or dispersion of quantitative data. Those terms are just used more or less interchangeably. We also use the range as a statistic for the variance of the data, and in practice what you'll learn to do is compare the IQR and the range. So the range, you might recall, for this data was 39 marks, and the IQR is 9 marks, which is about a quarter of the range. So the IQR, half the students are sitting within a sort of 1/4 of the range. So let's just look at the statement here of everything we've calculated so far. We've got the minimum 53, the lower hinge or Q1 63, the median 65, the upper hinge 72, and the maximum 92, and from those we can easily calculate two measures of dispersion or variance or spread. The range, which is the maximum minus the minimum, Q4 minus Q0, that's 39, and the probably more usefully the interquartile range, Q3 minus Q1. And I've got a chart here which shows you what you see here is the marks of all the students sorted from smallest to largest, and you can see that it makes a sort of very roughly S-shaped curve, and that shape happens to be typical for student marks if everything is going reasonably well with the way the marking is done with the assessment. So when I'm examining a set of student marks, one of the things I actually look at is to see whether there is, approximately this kind of S shape. Doesn't have to be exact, but if it's really strange, if it goes, if it's a really strange shape, that suggests there's something a bit odd going on. Now the horizontal lines in this chart just show you the locations of the minimum Q1, the median Q2, Q3, and the maximum. And that's just another way of looking at the spatial relationships in the data. So I'll end this video here. In the next one we're going to move on to the very important topic of identifying outliers. Thank you.